Hello everyone, my name is Bhavya and today I'm going to discuss about ER models. So these are the table of contents which I'm going to discuss in this video. So let us first move forward to discuss about introduction to ER model. ER model is a model for identifying entities to be represented in a database, and how these entities are related, that is also shown by the ER model. The ER data model uses enterprise schema, that means the overall logical structure of a database graphically. This ER diagram is a structural format of the database. ER diagram explains the relationship between among the entities, which I've already discussed on the upper line, and these ER models are used to model real world objects like person, car, company, and the relation between these real world objects. So why we use ER diagrams in DBMS? ER diagrams are used to represent ER model in a database, which makes the easy format or easy way to convert into relations. ER diagrams provide real world modeling of objects, which makes the intently useful. ER diagram doesn't need neither need technical knowledge and not hardware support. These diagrams are very easy to understand and easy to create even for naive user. It gives a standard solution for visualizing data logically. So what are the symbols that are used in ER model? So these are the 6 symbols we mainly use in ER model, that is rectangles for entities, ellipses for attributes, diamonds for relationships, and lines to represent between attributes to entities or entity sets with other relationships, or double ellipse for multi-valued attributes, and double rectangle for weak entity. So let me visualize those things. So these are the things. Rectangle means entity, weak entity means double rectangle, diamond means relationship, attribute means ellipse, and dotted ellipse means derived attribute, and double ellipse means multi-valued attribute. So let us learn about components of the ER diagram. So ER model consists of entities, attributes, and relationship among entities in a database. So entity is divided into mainly two types, strong entity and weak entity, and attributes is divided into mainly 4 types, key, composite, multi-valued, and derived. And relationships are also 4 types, one to one, one to many, many to one, and many to many. So let us discuss about them in deep on the next few slides. So what do you mean by entity? Entity can be an object, person, place, event, or anything that stores in a database. In relationship diagram I'll show you this. So this is an entity, student is an entity, and course is an entity, and this is a relationship between them, means student study courses is the relationship between them. So weak entity means which doesn't have another entity, and it is represented by double rectangle. And here how it is represented, a classroom and school. And one more important point is a weak entity is dependent on another entity, which means the strong entity, which have attributes. So let's move forward. Let us learn about attributes. And attributes describe the properties of the entities, and these are represented by ellipse. And attributes are mainly of 4 types, that is key, multi-valued, composite. So attributes here, the student is an entity and the attributes are roll number, age, address, and name. So let us move forward to learn about more described details about attributes. Key attribute. The key attribute is used to represent the main characteristics of an entity, which is also known as primary key, and it is represented by an ellipse. Within the text underlined, here you can view the roll number is underlined text. That means it is a key attribute of this entity. So student is an entity and the roll number is a key attribute of that entity. Composite attribute means the attribute which may compose many other attributes is known as composite attribute. Component is attribute is represented by an ellipse, and the ellipse is converted in connected with other ellipses, then it is known as composite attribute. Here we can view name is an composite attribute, and it is connected with 3 other attributes, that is first name, middle name, and last name. So here name is an composite attribute. So let us move forward to discuss about multi-valued attribute, an attribute which can have more than one value, and these attributes are known as multi-valued attributes. And this is represented by double oval, or it can also be said as double eclipse. So here phone numbers can be many. So if a student is there, it could be his mother phone number, father phone number, or own phone number, and maybe have two or three phone numbers. So it can be many ways to have the phone numbers. It can be multiple. So it is a multi-valued attribute. So derived attribute means which is derived from other attribute. It is known as derived attribute, where composite attribute which derives the attributes, and derived attributes which is derived from other attribute. So it is represented by dotted oval or dotted ellipse or dashed ellipse. So here age is an uh, derived attribute which is derived from date of birth. So by learning date of birth we can actually calculate the age. So in this way age is a dashed, dotted, or derived attribute, whatever you can call. And let us learn about relationship. A relationship is used to describe the relation between entities, and it is represented by using a diamond or a rhombus. So here student and course is an entities which we have, and studies and relationship between the two entities. So there are mainly four types of relationships. They are one-to-one, one-to-many, many-to-one, and many-to-many. So let us learn each of them. So one-to-one relationships, when only one instance of entity is associated with one relationship, it is known as one-to-one relationship. Like one student has only one identification card and their particular roll number. So only one student has one particular ID card. So one-to-many means when one instance of entity left and more than one instance of right, means one entity can be connected to many other entities. It is known as one-to-many. Here you can view the example. Then for example, we are purchasing anything on Amazon, and there is a single customer, that means from our side, and we can place many number of orders on Amazon simultaneously, many number of orders. So it is a relationship, one-to-many relationship. So many to one relationship means, so there are many instances and only one instance on the right is left, means there can be many students who can be enrolled into a course. So it is an example of that. So for example, AECT exam, AECT internships, many students applied for a single course. So it is an example of that. And many to many means many number of entity of instances on the left connected to many number of instances on the right, it is known as many to many relationship. So here an example for that, many number of employees is assigned to many number of project. When it comes to software projects or any other projects, so many number of people work on same project in order to get the project successfully. So these are the notations of the ER diagram. So it is one-to-one. So already we have discussed about relations. So they are presented by using these notations. This is one-to-one. This is one-to-many. This is many-to-many. And this is one or more, one and only one, zero or one, zero or many. And here is an example that company, employee, and projects are the are the entities, and these are the relationships between them which are represented by these notations. So you can use this example in order to get deeply detailed about the notations of the ER diagram. So we also need to learn about other topic, means that is cardinality, in order to learn in deep about and how to use the ER diagrams, how to draw them. So cardinality defines the numerical attributes and the relationship between them. So this is same as relations. Relations, they are one-to-one, one-to-many, many-to-one, and many-to-many. And this is the relationship cardinality, and they are represented by using this things. So these are the difference between the relations and cardinality. So it is called as mandatory one, mandatory many, optional one, and optional many. These are also called as the cardinality relations. So how to create an entity relationship diagram? So how we can draw the diagram? So this is the procedure. So first we need to identify entities, then we need to identify the relationship between those entities, then we should identify the cardinality, means how they are related, and then identify the attributes of these entities, and then we can create the entity relationship diagram. So let me give some of the examples of the entity relationship diagram that you all can understand that how we can draw the entity relationship diagram. So let's move forward to that. So entity relationship diagram of library management system. So library management system has a database that shows relationship between entities such as book, publisher, member. Since this is simple, it has only 3 attributes. I'm taking only 3 entities, and other systems can be more complex with significant number of entities such as staff or anything else. So here book is an entity and these are the attributes which I have taken according to me, and you can change according to you. And this is publisher and other, this is publisher entity and member entity, and these are the attributes which I have taken. And in this example I have taken one to one to many, and that means relationships. A member can borrow many number of books. This is the relationship between them. And but only one reader can borrow one book. This is another relationship. So the relationship is one to many. So let me represent the ER diagram for this, and also I'll also explain that how we have drawn this. So we have already discussed that books, publisher, member, and borrowed by, we are going to use them. And so these are the attributes of the books, and these are the attributes of the publisher, and these are the attributes of the member, which means the expiry date or vagera vagera, and these are the attributes of borrowed by. In order to learn that which member have borrowed that, so these are the relationship between them. So this is the relationship, and here is also a relationship between them, and here is also relations. So in this way we draw the examples. We divide the entities, the relationship between them, and the attributes of them in order to get a deeply understanding of the given scenario in detail. So let's move to another example. ER diagram of online shopping system. So this is a vast thing, vast scenario that everyone should do. And here we have entities like website, customer entity, products, the products which are available, admin who can see that who have been ordered anything, shopping cart which we regularly use to see which is on a shopping cart, and registration when you have first entered into this. And these are the relationships which I have mentioned between them. And this is a complex ER diagram for online shopping system. And first we have seen that it is the domain and app name and website or mobile application that it can be, and customer delivers. So this is some of the attributes here used for these entities. So there's a lot of attributes for the entities because it's required in an online shopping ER diagram. So this is another React diagram for banking system. So this banking management system illustrates critical information about the bank, that is bank entity. We have customer entity, branch entity, account entity, and loan entity. You can take many number of entities and the attributes which you can, but I am just taking them, and the relations between them is mentioned below. So in this way I have drawn the ER diagram for the banking system. That is, bank means we just need bank code, name and address. That's it. We doesn't need any other thing. If in case you can also need that code of that, or then you need branch you need branches, that how many branches that this bank have. This is also an information which is needed. This has a relationship between them. So in this way the banking relation is also maintained. So it's an example of that. You can understand it deeply. Just pause the video for a second and you can understand this diagram in detail. That revise the concepts I've explained in previous, you can understand this very easily. So thank you guys for watching this video.